So it's going to look like a huge parentheses, of course. So when I type send this set current speed, so that's going to send a message or call upon this, which is going to be Tesla, and then it's going to call the function set current speed, which is going to pull it from car because we've already ran super new. When we run super speed, it's going to look for argument new speed, which is going to be this. And of course, the other thing we need to do is that we can't just call current speed, we have to use our getter. So we're going to use get current speed, but we can't just call that, we have to do our send. Send this, get current speed. Because what ends up happening is if I type get current speed, it won't work because this is out of the scope of Tesla. Or rather, similar to this, we just have to type send this because it's kind of the recursion. So it's going to call upon the class to therefore pull our getter. So that's why I have to write in send this, then the function get current speed. That's going to go ahead and make this entire parentheses here, whatever our current speed is, then it's going to go ahead and add 10. Then whatever this number is, whether it's 10 or otherwise, then it's going to say, okay, send this, then we're going to use our setter, set current speed, to whatever this is, 10 or otherwise. Hooray! So that's kind of the huge roundabout way, or rather, what ends up happening with typing in with subclasses is we just have to be able to type send this every single time, and then using our setters and our getters every single time. I was originally trying to just do get current speed without using the send this, and it didn't work. Then sometimes I was trying to use the set function by just calling the field current speed, and it didn't work. This is ultimately the syntax that is necessary to make this work, and at the same time, it's actually just good coding practice to always use your setters and getters. For reasons that doesn't matter. I'm not even going to go into them. As then, it's just good practice. Great. So now that we've done that, we're going to go ahead and give the ability to break. So this ends up being effectively the same code again. So I'm just going to copy and paste. Boop, boop, boop. So define public, accelerate, define public. So this is going to be a break. And it's going to go ahead and grab set current speed, except instead of adding 10, it's going to subtract 7. So this is going to create a break. So anytime we accelerate, speed goes up by 10. Anytime we break, speed goes down by 7. We did that in class. Great. Again, I'm not worrying about AMC. Now, we're going to give the subclass limits of 0 to 110 for Tesla. And again, AMC I'll do later. So we want the speed limit to be 0 so that we can't go negative for braking. And we want it to be 110 when we accelerate so that it cannot go faster to 111, etc. So what I ended up doing for this is I just did an if statement. So I'm going to go ahead and just jump into my accelerate function here. So what I wanted to say is if the speed, what I had done for if the speed is greater than or equal to the current speed, I'm sorry, 101, excuse me. If the current speed is greater than or equal to 101, then I want it to give me my max speed. So return 110, because I don't want to go over 110. And the reason I picked 101 is because 101 plus 10 is going to give us 111. So this is effectively the absolute minimum, and anything above that we don't want. I originally had 110 when I first wrote this code because I'm like, oh, we don't want to go over max speed. But then I ran into this exact problem where when I had reached max speed and then I broke once, it was 110 minus 7. I got 103 plus another 10. Then that's going to end up giving me 103 or 113 for instance. So anyway, so when our current speed is equal to or greater than 101, simply return 110, which is our max speed. Otherwise, we're going to do our normal business that we have, send this set current speed. Now, of course, same thing here. I can't just call my current speed, I have to send this and use my getter, get current speed. Okay, so when it's greater than 101, we're going to go ahead and return 110, and then otherwise we're going to go ahead and increase our speed as normal. Braking is literally going to be the same. If, and then we're going to go ahead and say is, so if our current speed, and then I'm just going to skip that business, I'm going to type it in, it's our getter. So when we get our current speed, boom. When our current speed is greater than or equal to, and I'm actually going to say 7, because 7 minus 7 is 0. So if we have 7, we subtract 7, it's going to return 0. If we have anything less than 7, 6, 5, 4, 3, 2, 1, it's going to give us a negative number. So instead of doing that, we want it to just return 0. Otherwise, we brake as normal. So boom, that's all complete and done. And I just got to make sure, did I, because I added a thing, that it actually has an extra parentheses there to close or define. Okay, perfect. So that completes this one. Give subclass the ability to accelerate and brake. Give the speed limits from 0 to 110. The next thing is give subclass the ability to come to a max speed and a full stop. And then add to code to solve problems. Got it. I wrote that was vague on purpose for solve problems because it was these problems. That effectively when we start, what ended up happening is the way that the classwork, the assignment was written, it was saying do this, then you're going to run into this problem. Then I want you to create the max speed and full stop functions, and then go ahead and use them in your code so that you're able to effectively not hard code 110 and 0, if that makes sense. So what is going to happen is I'm going to go ahead and define public. I'm going to create a, let's say, full acceleration, just for the sake of simplicity, so I know what I'm talking about. So when I reach max speed, I basically want that to set the current speed to 110. So what I'm going to do is I'm going to do my setter, set current speed, and then that's going to take 110. So the purpose of doing this, and so is that it allows me to, instead of hard coding 110 inside of my accelerate function, I can go ahead and just call full accelerate. Because it's similar to when we worked on creating windows and such. When we would type width, it was I think in week 1, we typed like define width as 10 and then define height, as 5 or whatever. That way when we wrote our code over here, I could just type in width and height instead of the numbers 5 and 10. That way if we ever needed to change the width and height, it was very simple and very easy to do. So it's the same principle, but it's happening within this entire subclass. Is I'm creating this max speed. I'm calling it full acceleration, but it could literally be called max speed or whatever, at 110, so that if I ever wanted to change the max speed, or if I wanted to create a second class like the AMC with a different max speed, I could effectively just very quickly do so. So that's the purpose of creating this full acceleration and full stop. And again, a lot of this is just the same code, so I'm actually just going to copy and paste this. Copy, oops, and then paste. So what ends up happening is instead of full acceleration, I'm going to call this full brake. And then that's going to set our current speed to 0, which again, when we're braking, instead of hard coding the 0, I can just call full brake. All right, so that's perfect. So now that I've created these, give subclass the ability to come to max speed and full stop, and add to code to solve problems, that's when I was talking about this, adding full accelerate into our accelerate function and adding full brake into our full brake function. That's actually why I call it full accelerate instead of max speed, is because I named my function accelerate. But that's just a me thing. You can name it whatever you want. So now this ends up helping us not have a hard code, and then we can change our max speed or our minimum speed whenever we want in a much easier fashion. Now that this is complete, that actually ends our entire subclass that we wanted to create for our Tesla. So this is now done. And the good news is that because we still have our defined Tesla here, then now this Tesla Z is going to contain all of the information of car, and it's going to contain all of this information that we've given to Teslas. If I create now, and let me just go ahead and do the simple version, boop, 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 and I'm going to do this under the Tesla, just for organization, for my own personal purposes. If I define instead of Tesla AMC, so AMC is going to be a class of car. We call super new. It's going to inherit all the information of car. This is a new subclass. Yes? And boop, AMC. The difference now between AMC and Tesla is that with a Tesla, I can do my full accelerate, I can accelerate, and I can brake. And, you know, bring it to full speed and blah, 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 all that business. With an AMC, I can't. I only have this information. So that's effectively how you create a subclass, and then the difference of the scope of it. Because in Tesla, I coded these informations, then they are in Tesla, and then as this code is written right now, they are not in AMC. So AMC does not have the ability to accelerate and decelerate. Ultimately, what ends up happening is because he asked us to do the same code with different numbers for both classes. The good news is I can literally just copy and paste this. Boop, boop, boop. Here we go. This is AMC. And again, instead of changing it multiple times, my max speed here is going to be 65. Minimum speed is still 0. And then we're going to go ahead and, let's see here. So if our max, great. Max speed is 65, full speed is 0. Now let's fix accelerate. The AMC is going to accelerate by 2. So instead of by 10, change that to a 2. Now what ends up happening here is if my max speed is 65, whenever I add, when I'm at speed 64 and I add 2, that's going to give me over the speed limit. So that's why I'm changing this number to 64 whenever whenever my current speed is equal to or greater 64, then we're going to go ahead and return our full speed. So it's going to be, 63, excuse me. That's my wrong math. 63 plus 2 returns full accelerate 65. Perfect. If we have 64 plus 2, we can't go over 65, so it's going to return 65. Otherwise, we're going to go ahead and increase the speed by 2 as normal. Braking, same thing. We're going to go up by 1, in which case this one's kind of redundant, but because I just copied and pasted it, then great. So if my speed is equal to 1, then it's gonna return 0 because we're braking by 1. If it's less than 1, so if it's 0, then it's gonna again return 0. And that's fine. I mean, it's extra code, but I'd rather have this than something that might break it in case, I don't know, maybe the AMC class gets an upgrade and then all of a sudden has better brakes and better acceleration. Then it's really easy to change. And then I don't have to like create all of this again.